So your objectives today, you're going to be able to identify abiotic factors. You're going to be able to describe the effects of sunlight and temperature on an ecosystem, and you will be able to explain why water is one of our most important abiotic factors. Those are our goals for today. So, all the non-living factors of an ecosystem are called abiotic factors. So, we talked about biotic factors. Biotic, bio, things related to life and living things. And then now we have abiotic, so putting that A in front of this means the opposite here. So now we have non-living things like the air, the temperature of an area, the amount of moisture available, light, soil. All of those things qualify as abiotic factors. And abiotic factors are important because they usually determine what organisms or what biotic factors are able to exist in a place. Okay? So the temperature of an area determines which organisms will survive there, right? There are plants that can survive in an Arctic ecosystem that wouldn't be able to survive in a tropical ecosystem, okay? So the abiotic factors are the ones that are determining what biotic things are living in those areas. All right, we're going to do a little activity as a sort of check for understanding, okay? So there's a spot on your notes where you can make a list of all of the abiotic factors or all of the non-living things that you have in your environment that you have encountered since you woke up this morning. So think about when you woke up, walk yourself through your morning, all the activities you did, and think about all the non-living things. You don't have to list every non-living thing that existed in the spaces you were in. Think about the ones that you interacted with, right? The ones that impacted you this morning. And then once you've made your list, you're going to put it in the table on your notes as either essential or non-essential. The way to tell the difference here is essential being could not have survived without it. Now, I know some of you will be tempted to put coffee on that list. It is not essential for life, okay? And then non-essential would be things that you ran into, but that you could have lived without, right? So like your cell phone is non-living, but you wouldn't die if you didn't have your cell phone, though you might feel like it. So, what are some of the things that we think are on our list that are maybe not so necessary that we ran into this morning? Chris's car, okay. A pop.
Cell phone.
Your cell phone. Tape. Yep.
Sorry.
Tape, scissors, markers, faucet. Okay, so these things are not living, but they're not necessarily crucial to us surviving. What about some of the things you ran into, the abiotic things that you definitely need to survive? Food, absolutely. Food is an abiotic factor that we definitely need to survive. Now, some of the food that we eat was at one point in time living, right? So that might qualify almost more as a biotic factor, but there are things that we eat that were never necessarily living. So, what else? Something to drink. Specifically, what drink is the most important to our life? Water, right? You probably ran into water this morning. That one's pretty important. What else? What else do we need in order to survive? Clothing, yes. Particularly here in the Midwest where our climate is approaching winter, clothing is very important to our survival, right? It helps control our temperature, keep us from being exposed to the elements. Any other things we need in order to survive? We think that's it? I would argue things like air that you're breathing right now might maybe be important, right? Potentially some of the things we talked about, like sunlight and temperature, those might be important too. Okay. Shoes to protect our feet. Yep, absolutely. So we just talked about why the items that are in our essential column are necessary for life. Can you think of any other organisms that share similar essential needs with us? I would say, let's say, like mammals and reptiles and birds and amphibians for some portion of their life need air. So there are some other organisms that need air. What else do we have in common with other organisms? Well, maybe let's switch gears. What other organisms can we think of that have totally different essential needs from us? Think of anything that's living that might need something that you don't need.
Fur.
Right? Some animals have fur as opposed to clothing, so then they don't need clothing. What about a bacteria cell? What things might it need or not need? Right? So there's lots of different organisms with totally different needs than us. If an organism is going to live outside in the Arctic, it's probably going to need like a fat layer to help insulate it. It's going to need claws to help it get its food. So, and then as far as abiotic factors that are involved, it's going to have different needs than us, right?
Yeah.
Okay. Let's talk about some specific abiotic factors then. We'll start with sunlight. So we already learned in previous chapters in class that sunlight is a form of energy and that it's transmitted to Earth as radiation. Objects can do one of the following things when sunlight strikes them. They can reflect the sunlight. Okay, so that just means that they bounce it back. They can transmit the sunlight, which if they're transmitting it, that just means they're allowing it to pass through. So if you think of like a glass window, right, or a bottle of water that you can see through them because they allow sunlight to pass through them. Or they can absorb that sunlight, which just means they take it in. So if you've ever been outside on a sunny day while you're wearing a black shirt, you've likely experienced what it's like to have something absorb sunlight, because that black shirt gets very hot very quickly, right? And that's because it is taking in that sunlight as energy and warming up. The amount of light that an area gets determines which plants can live in that area. Some plants, as I'm sure you have observed in your everyday life, can survive on less sunlight than others. Okay? So, when an area only gets a specific amount of sunlight, that determines that specific types of plants can live there, and then sometimes it decides that some plants cannot live in that area. Plants change sunlight into energy they can use through a process that's called photosynthesis, which I'm sure you've been hearing about since probably third grade. Okay, so you're familiar with that, which is why all plants need some level of sunlight. It just depending on the plant, they may need more or less than others. Okay? And because all animals either eat a plant or eat an animal that eats a plant, the availability of plants and the availability of sunlight also affects other organisms. So if you're an animal that eats a lot of plants, you're not going to be able to survive in an area that is very low sunlight because that area is not going to grow a lot of plants. Similarly, if you are an animal that eats plants, you're not going to be able to survive there either because there's not enough plants to support a lot of animals, and then you can't eat a lot of animals because there's not a lot of them around. So even if you're not a herbivore and not a plant, the amount of sunlight in an area also affects your ability to survive in that area. I'm sure those of you who are involved in farming know there's just some areas you can't grow crops in. Now let's talk a little bit about temperature.
Is that blood dry this week?
Mm-hmm. The amount of sunlight that's in an area is going to directly affect its temperature. We observed this in a previous chapter, right? We looked all about how the sun heats the earth, and we even went outside and measured how sunlight affects temperature changes in objects. So we know how much sun an area is getting is going to have a really strong impact on its temperature. And we know that because the earth is curved, some areas of earth receive more or less direct sunlight than others, which means that the areas that are curved towards the poles are going to be much cooler in temperature than the areas directly on the equator where they get most of that direct sunlight. Okay? The temperature range of an area determines the kinds of organisms that can survive in that environment. So, like we said, if you're a penguin, you're likely not going to do well in the middle of the desert because you're adapted to live and survive in an environment where the temperature is much cooler. So whatever that temperature range is, then organisms have to adapt to survive in that range. Even places like here in the Midwest where we have seasons and the temperature range changes seasonally, organisms have to be able to change and survive in those changing temperatures. So you'll see lots of different plants and animals here than you would at the equator or at the poles. Lastly, let's talk about water. Water is a very important abiotic factor. Okay? It's important to almost all life, and it has three things about it that make it very important, that are the reason why a lot of life is based around water. Okay? The first of those is high thermal capacity. Okay? Big fancy words, just means that it's really difficult to change the temperature of water. Anybody who's ever tried to boil water on the stove knows that it takes a while, right? If you put your hand on that stove, you would almost immediately burn your hand, but it takes a really long time to heat that water up. That's because it takes a lot of energy to change the temperature of water, much more energy than many other substances. If you have the same amount of metal, like iron, as you do water, it takes almost 10 times as much energy to change the temperature of water 1 degree as it does to change the temperature of iron 1 degree. It's a lot of energy. So, what does that mean for the world in general? Well, it means that if an area of land is near a large body of water, that water is going to absorb a lot of that heat energy, that sunlight energy, and it's going to make the temperature in that area more stable. So it means that it's going to take a lot more energy to raise or lower the temperature of that area. So the temperatures are going to be more stable across the board. Next, water is polar. This means that 1/2 of a water molecule is positively charged and 1/2 of a water molecule is negatively charged. This happens because, and this is a little more information than you necessarily are, I'm not going to expect you to be able to draw me this picture or explain it to me this way, but I want to show it to you because we have this information, okay? So a water molecule is one oxygen bonded to hydrogens, okay? And the reason they're connected is because of electrons. So the hydrogens have electrons and the oxygen has electrons. But because the oxygen is so much bigger than the hydrogens, it tends to attract more of the electrons to be around its side of it than the hydrogens would, which means this side of the molecule is negative and this side of the molecule is positive because electrons have a negative charge. Okay? So that's what we mean by polar. We mean one half of the molecule is slightly negatively charged and one half of the molecule is slightly positively charged. This makes water what we call a universal solvent. Okay? When you mix two things together and one of them dissolves in the other, what's happening is that the ions that make that substance up are being broken apart and spread out evenly throughout the substance. So, because water is polar, it's really good at doing that. Okay, which is why it's so easy to dissolve things like sugar and salt and things like that in water, which makes it ideal for delivering those nutrients to your body and delivering them throughout your body, which is why water is so important for life. Well, one of the many reasons. And the last thing that we should talk about is that water has a neutral pH. pH is a measure of how acidic or basic a substance is. Okay? So it's a scale. It goes from 1 all the way up to 14. 1 is very acidic. 14 is very basic, and 7, which is right in the middle, is neutral, which is what water is. Okay? But even though water is neutral, when it dissolves things in it, its pH can be changed by whatever is dissolved in it, and many chemical reactions will only take place at a specific pH level. So being able to help regulate the pH is important. Okay? Salt water is very, very, very slightly basic. It's like an 8 on the pH scale, so one step above neutral. But if salt water was more or less acidic than that, it would not, the chemical processes that help coral reefs form would not be able to take place. So it's very important for the pH of a system to be at the correct level in order for life to continue there. And water helps accomplish that. All right, that should be the end of our notes for today.